So if you're watching this video, hopefully you've already watched the front side video, the first video that we had that was all on the first page of the notes. So we're going to start talking a little bit about the actual equations of the lines that we have. So we have two equations of lines that we're going to be focusing on. We're going to have slope intercept form and we're going to have point slope form. Oops, excuse me. There we go. The first one should be really familiar. We talk a lot about this in algebra. Slope intercept point. And again, we mathematicians, we're not very creative, crazy people. If we say slope intercept form, that's because in our equation, we give you the slope and you have the intercept, right? So M stands for the slope. And just as a note, I always like to think of slope or that M as how you move. B stands for the y-intercept of the line, right? Where it crosses the y-axis. I always think about that as where we begin. So our x and y's, those are actually going to stand for coordinates that we have on that line. And that's going to come in handy a little bit more than what we've used in the past if we need to plug in and actually solve for the intercept, given that we have a slope and a point. Another equation of a line that we can look at is our point slope form. Again, point slope is exactly what it seems like, right? We have a point and we have a slope within the equation of this line. So if you notice, kind of similar to what we had done before, you have your x1 and your y1, and those are going to represent just any point that is on that line. And your m, of course, just like we had up above, is going to be how it ends up moving. So we're going to end up using both of these two equations of lines, either one for graphing an equation based on having one of those two, or two, we're going to rewrite our stuff in those forms, given that we have a certain amount of knowledge. Let's start with the graphing piece. Now I'm going to try to graph these in different colors as we go so you can kind of tell which one's which. So I'm going to start here with this purple line. So we've got our y equals 3x minus 4. So just like we set up above, our 3 and our negative 4 are going to be important. This is in slope intercept form. So that y equals mx plus b. Your m value is going to be 3. That's your slope. And your y-intercept, that b value, is going to be negative 4. And traditionally, we've seen it just written as a negative 4. I'm going to write it today as 0, comma, negative 4. Just to remind you that that is, in fact, a point that we have on that line. So I'm starting with that b value. I'm going to go to 0. And I'm going to go down 1, 2, 3, 4. That's my first point there. And then my slope, again, it says that it's 3. We know that that really means 3 over 1 because we need to rise and run with this line. So I'm going to go from the point that I graphed. I'm going to go up 1, 2, 3 over 1. And once I have 2 points, I can draw a line. And make sure that you are not doing what I'm doing and make sure you're actually using a ruler when you draw these lines so that they're nice and straight. All right. For my second equation of a line, which I'm going to draw in red, it's a little bit different. So this one's going to be from our point slope equation. So I always like to start with my slope. I think it's the easiest piece to find. And again, if it helps you to write, it's going to look a little messy up here since I'm kind of laying it on top of it. But if it helps, I would have that equation right there. So you see, hey, here's where the m is. Here's where the m is down in this equation. We know that the slope is negative 3 or negative 3 over 1. For the point, and this is kind of an interesting thing, and I'm going to go back up for a second if the computer cooperates. There we go. When we look at this, right, in our equation, we have y minus y1. Notice this is always going to be a subtraction. So even though this looks like a minus x1, it's really just an x1 over here. Even though it looks like a minus y1, it's just y1 here. So the signs are going to be a little bit different than what we see. When I go to pull out the point from this equation, over here by the x, we have this positive 5. So remember, that negative is always there. So instead of a positive 5, it's really like it's minus negative 5, which means when I go to write my x term, it's actually a negative 5. Here, y minus 2. We said it's always a minus, so just this part here is my y value, which means it's just a 2. That's, I think, the biggest thing that people have issues with when they look at point slope form is making sure that they get the correct signs for their points. Once we have that, we can go to graph it. We're starting at -5, 1, 2, 3, 4, 5, up to. So we're starting at this point right here. And since my slope is -3/1, I'm going down 3, 2, 3, over 1. And once I have 2 points, remember any 2 points make a line, so I can draw my line in there. So those would be my 2 graphs from those equations. Looking at the next 2, we've got y equals 2. So notice this one's a little bit weird. Technically, we could think of this in slope-intercept form and say that this is y equals 0x plus 2. But we can also think, and I know I put it on the first page of the notes, if you need to go back and take a look, you definitely can. Anytime that we see y equals, it's always going to be a horizontal line. Anytime we see x equals, it's going to be a vertical line. So in this example, when we say y equals 2, that means every point that we have on that line should have a y value of 2. That's why we end up seeing this horizontal line when we go to graph it. Notice if I start looking, we've got 0, 2, 1, 2. Well, I'll draw these in so you can actually see it. 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, right? All of these have 2 as their y value, which is what makes that horizontal line. On the flip, we have a x equals 5. That means we're going to have a vertical line, and it's going to be the same thing. Every point that we have is going to have a 5 in the x value. So let's go over to 1, 2, 3, 4, 5. I'm going to place a point right there, and I can draw in a line, a vertical line. And if you notice, just like before, we've got 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and so on and so forth. All those x values are always going to be 5. So those lines tend to be a little bit tricky, but they tend to be pretty quick too if you know what you're looking for. The last 2. These are kind of untraditional lines, and I'm going to do green. We haven't used green yet. Let's do that. A little bit untraditional for my slope-intercept form. For the first one, we've got y equals -2/3 x. That one's kind of weird because right now it doesn't have a b value. If we don't see anything behind it, though, I can think of that as a plus 0. So when I'm going to label my slope and my intercept, my slope is -2/3. My b value, which I just added in, is actually 0. So this one starts at the origin. It starts at 0, 0. My slope is -2/3, so I go down to over 3. 1, 2, 3. Just so you see it as well, remember for the slope, I could also think of this as going up 2 and to the left 3. Either of those are going to work when we're graphing our lines. Last one that we have is we have y equals x plus 3. I'm going to use this yellowish color for this one. This is also in slope-intercept form. My slope in this case, right, the number right in front of that x, well, we don't have one, but we can think about that as a 1, right? So my slope in this case is going to be 1, or 1/1. My intercept, and again, I'm going to write it as an ordered pair, 0, 3. I go over to my graph, 0, 3 is at 1, 2, 3. It's right here with a slope of 1/1, rise 1/1, rise 1/1, and we can graph that line. So these are 6 different examples of of lines that we could come across and how we can graph each one of them. One other thing that we're going to be able to do, and this should be the last part of the notes, is using information that we have, such as points and slopes, we should be able to write the equation in slope-intercept form, and this should say slope-intercept form right here. I'm going to be lazy and write slope int. And we can also write it in point slope form. So these are going to be the directions that we go through. So notice for slope intercept form, step one, find the slope between 2 points, which we already know, right? That was our m equals y2 minus y1, x2 minus x1. We're plugging that slope into the coordinates from one of the points into this y equals mx plus b form, solve it for b, and then rewrite it with both the slope and the intercept value in there. If we're solving using point slope form, just like the directions say, we're going to find the slope between the 2 points. Notice, same first step. And this one's a little bit quicker because we can plug the point directly into my point slope equation. There's an optional third step. We could, if you want to, you could solve for y by plugging it. You could solve for y, and that would actually put it in your slope intercept form. But we'll tell you very specifically if we want you to be able to do that. So in these examples, I'm going to kind of split it right down the middle. I'm going to do these two over here on the left as my slope intercept form. And then I'm going to do these over here as point slope form, just so that you get the chance to see both of them. So using my directions, right, it says we want to find the equation of a line that passes through these 2 points. Step one, it says that we need to find the slope. So just like we've been doing, y2 minus y1 over x2 minus x1. We've got my x1, y1, x2, y2, and I'm going to plug them in. So my slope is going to be 0 minus 2 over 3 minus 0. And that simplifies down to negative 2 over 3. When we go back now to find the b value, we're going right here to step 2. It says plug in the slope and the coordinates from one point into the formula. So we've got my y equals mx plus b. I'm going to plug in a point, and I'm going to plug in my slope, and then I'm going to solve. So I'm going to use, doesn't really matter, but I'm going to use this one, all right? So I'm going to go through, and I'm going to plug in my y value is 2 equals my m value we just said was negative 2 over 3 times, well, my y or my x value here is 0 plus b. Notice the only variable I have left now is b, and I can solve. So I'm not changing anything on the left side. 0 times negative 2 over 3, that's actually 0. So this whole part actually goes away, and I get that b equals 2. Now that I've solved that equation for b, notice step 3. It says step 4 is rewrite y equals mx plus b with the slope and the intercept that we found. So it'd be y equals, my slope was negative 2 over 3 x plus 2. So again, we're finding the slope, plugging in the slope and the coordinates from one of them. And again, if we had done the other one, we still would get the same answer. And then when we solved for our b value, let's do the same thing here. So we're starting by finding the slope, and take a look. Woohoo! Actually give us the slope, so we don't have to solve for it. We can go right to the second step, which is plugging in the slope and the coordinates into y equals mx plus b form and solving for that b value. So my y value is negative 2. So negative 2 equals my slope, 2, times my x value, which is 4, plus b. 2 times 4, let's simplify it out. We get 8. And now we're solving for b. I'm going to subtract 8 on both sides. Ooh, that's a terrible 8. Wow, that was weird. I don't know why that switched. Sorry about that. And you end up getting negative 10 is your b value. Now that we have the slope, we have the intercept. I'm going to write this as y equals mx plus, and I'm actually going to put it as minus 10. I could put plus negative 10. That means the same thing. And that will be my equation. Now let's try some of these point slope forms. So For the first one, it says we want the equation of a line that passes through the point 1, 3 with a slope of 2. So remember, here's my equation. We've got y minus y1 equals m x minus x1. Easiest one, I always like to plug in my slope first. We know the slope in this case, it is 2. Now, when I go to plug this in, the y and the x, kind of like when slope-intercept form, at the very end, we still had our y and our x just as y and x. Those are going to stay the same. All right. And we're just going to plug in the 3 for my y and the 1 for my x. And notice it says y minus. So y minus, let me plug in the 3. Over here, it's x minus. I'm going to plug in the x value, which is 1. That's actually the entire equation. So it's really nice when we have a slope and a point to use this form because it's just simply plugging in the slope and the point and you're done. You don't have to do a lot more solving besides that. The last one is problem D. It says we're looking for the equation of a line that passes through these points. First, I notice I do not have a slope. So I'm going to start by solving for that slope. So y2 minus y1, x2 minus x1. So our slope is going to be 4 minus -2 over 6 minus 3. 4 minus -2, that's going to give me 6. 6 minus 3 is 3. My slope is going to end up being a 2. Now we're going to plug it in to our point slope form. Even though we have 2 points, it does not matter which one that we plug in. Either way that we write it, it'll still be the exact same equation of a line. I'm going to use the first one just because I'm always going to use the first one. Because again, I'm a creature of habit. I like doing the same thing over and over again, so I know I have a routine. All right, first thing I'm going to do, plug in my slope. I'm going to plug in my y minus and my x minus because those are always there. And now I'm going to plug in my points. So for y1, it's -2. So I'm going to plug in a -2. For my x value, it's a 3. So I'm going to plug in 3. We have this minus a -2. I'm just going to clean that up and say y plus 2 equals 2x minus 3. So for both of those, that would be how we go about solving or writing those in those different equations. So if you have more questions, make sure you talk with your teachers. Thank you for joining and good luck.